Hello, this is the last instructional video I will be posting for the school year. Woohoo! So in this final instructional video, we are going to review graphing quadratics and also talk about how we can use the graphs to solve. So today's topic is called quadratic roots. Or you can also think of them as zeros or the solutions or the x-intercepts. So I mentioned in the first instructional video when we were going over the vocabulary that went along with graphing quadratic functions, I said zeros, solutions, x-intercepts, and roots. These four words all get used interchangeably. They all mean the same thing. They're all talking about the points at which the parabola intersects the x-axis. All right, so roots, quadratic roots. This comes from the idea of using square roots to solve. Quadratic roots, also known as the zeros of the function because they are the x values when y is 0. They are also known as the solutions of the quadratic equation, or graphically, they are the x-intercepts. All right, I mentioned before that we have three possible outcomes. We can get two solutions. That happens when our parabola crosses the x-axis twice. We also saw that when we are using the quadratic formula, we can get two solutions. Or we could have a quadratic whose vertex is on the x-axis, so it's just barely going to touch the x-axis. So something like that will have one solution. And the solution will also coincide with the vertex. So the x-coordinate of the vertex, the x value of the axis of symmetry, will also be the one solution. Or we could have no solutions if your parabola is graphed entirely above the x-axis, or if it's entirely below the x-axis, you have no solutions because you don't cross the x-axis, you don't have any x-intercepts, you have no solutions. Okay, so how we use graphing to solve, we follow the same graphing procedures that we have done in the previous instructional videos. So the first thing I go through when I'm given a quadratic function is I'm going to identify that A is 1, B is 4, and C is -5. Then I'm going to get the axis of symmetry. So I abbreviate axis of symmetry as AOS. My axis of symmetry is x equals -b over 2a, or opposite of b over 2a. Well, b is 4, so the opposite of b is -4 over 2 times a is 1. So then 2 times 1 is 2. -4 divided by 2 is -2. So on my XY table, I find the middle, and that's where I put my axis of symmetry. I will also draw my vertical line on my graph. Then my vertex, I know the x coordinate is -2. So to find the y coordinate, I have to plug -2 in. -2 squared plus 4 times -2 minus 5. Make sure you're following order of operations and watch your signs. -2 squared is +4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. Minus 5 is negative 9. So my vertex is at negative 2, negative 9. Then I pick points on either side of my vertex. So going to the right, I'll use negative 1, 0, and 1. Going to the left, I'll use negative 3, negative 4, and negative 5. Don't forget, use the fact that it's symmetrical to save yourself a little bit of work. All right, when x is negative 1, negative 1 squared is 1. 4 times negative 1 is negative 4. So 1 minus 4 is negative 3. Minus 5 is negative 8. So when x is negative 1, y is negative 8. And then I get my mirror image point. When x is negative 3, y is negative 8. When x is 0, that's my y-intercept. That is the c value. When x is 0, y is negative 5. And then use symmetry to get another point. When x is negative 4, y is also negative 5. And then when x is 1, 1 squared is 1. 4 times 1 is 4. 1 plus 4 is 5. Minus 5 is 0. So when x is 1, y is 0. And then using symmetry, that means when x is negative 5, y is 0. So then I connect the dots, get my nice smooth parabola. Remember, no points. This isn't a V. This is more of a U. And then my solutions are my x-intercepts. You can also see them in the table. They're the x values when y is 0. So over here, I'm going to say in number 1, my solutions, x can be negative 5 or positive 1. Doing the same thing in the next one. I start by identifying my a, b, and c. So here, a is 1, b is negative 2, c is 1. Then I do my axis of symmetry. Find my axis of symmetry. X equals opposite of b over 2 times a. Well, here, b is negative 2. So the opposite of b will be positive 2 divided by 2 times a is 1. Well, 2 times 1 is 2. 2 divided by 2 is 1. So then on my graph, I draw my axis of symmetry. And I put 1 in the middle of my XY table. Then I find my vertex. I already know the x coordinate is going to be 1. I just have to find the y coordinate. So my y coordinate, I'm going to plug 1 in. 1 squared is 1. Minus 2 times 1 is negative 2. 1 minus 2 is negative 1. Plus 1 is 0. So when x is 1, y is 0. There's my vertex. Then I'm going to fill in around it. Going to the right, I'll have 2, 3, and 4. Going to the left, I'll have 0, negative 1, and negative 2. All right, when x is 0, this is my y-intercept. The y is my c value. So when x is 0, y is 1. Then use symmetry to get another point. When x is 2, y is also 1. Then I will plug in negative 1 next because it's smaller. Negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2. So 1 plus 2 is 3 plus 1 is 4. When x is negative 1, y is 4. Then using symmetry to get that when x is 3, y is also 4. And then doing this again one more time. When x is negative 2, y is 9. And then using symmetry, when x is positive 4, y is also 9. Connecting the dots with a nice smooth curve. No points, no V's. We want it to be U-shaped. Finding our x-intercept, our solution, the x value when y is 0. This problem has one solution, and that solution is 1. All right, moving on to the next example. Again, I start off the same way. I start by identifying that A is -1, B is 2, and C is -3. My axis of symmetry, x equals opposite of B over 2 times A. Well, B is 2, so the opposite is -2. Divided by 2 times -1 is also -2. -2 divided by -2 is +1. So again, on my graph, I draw my vertical line through x is 1. That goes in the middle of my xy table. And then to find the rest of my vertex, I know the x-coordinate is 1. The y-coordinate is -1 squared. 1 squared is 1. Make it negative. We get -1. Plus 2 times 1 is 2. So -1 plus 2 is +1. Minus 3 is -2. So my vertex is at 1, -2. Then I'm going to fill in the points around it. So going to the right, I'll use 2, 3, and 4. Going to the left, I'll use 0, -1, and -2. Well, 0 is our y-intercept. That's the C value. So when x is 0, y is -3. Using symmetry, I get that when x is 2, y is also -3. Then I'll plug in -1. -1 squared is +1, but then I make it -1. 2 times -1 is -2, so -1 minus 2 is -3, minus 3 is -6. So when x is -1, y is -6. Using symmetry, I get my mirror image point. When x is 3, y is also -6. And then when x is -2, y is -11. And using symmetry, that means when x is 4, y is -11. Then connecting the dots with a nice smooth curve. All right, now what we should see here is this doesn't touch the x-axis. So what that means, this problem has no solutions. And if you were to use another technique, if you were to attempt to use factoring or quadratic formula, you would see the same thing. All right, flipping it over to the back. My next example, again, I start the same way. I identify that A is 1, B is -10, and C is 16. I find that my axis of symmetry, x equals opposite of B over 2 times A. Well, B is -10, so the opposite of B is +10. Divided by 2 times A is 1, so 2 times 1 is 2. 10 divided by 2 is 5. So on my graph, I draw my vertical line through x equals 5. There's my axis of symmetry. That also goes in the middle of my xy table. Then finding the vertex. We've got the x-coordinate is 5. The y-coordinate is 5 squared minus 10 times 5 plus 16. Well, 5 squared is 25 minus 10 times 5. 10 times 5 is 50, so 25 minus 50 is -25, plus 16. we get -9. So my vertex is at 5, -9. All right, then we fill in around it. Going to the right, I will use 6, 7, and 8. Going to the left, I will use 4, 3, and 2. So when x is 4, plugging it in, I get y is -8. Then using symmetry, I get that when x is 6, y is also -8. Plugging in 3, I'm choosing to plug these numbers in instead of these numbers because these numbers are smaller. These are easier to do in my head, and because I know that I can use symmetry to fill in the second half of the table. So always work smarter, not harder. When x is 3, plugging that in, I get y is -5. So when x is 3, y is -5. Then using symmetry, that means when x is 7, y is also -5. Plugging in 2, I get y is 0. Using symmetry, that means plugging in 8, y is also 0. Connecting the points with a nice smooth curve. And then these x-intercepts, the x values when y is 0, are our solutions. So this graph has two solutions. They are 2 and 8. All right, in the next example, a is -1. I don't have a b value, so that means b is 0, and c is 9. So my axis of symmetry, x equals opposite of b over 2 times a. Well, opposite of 0 is still just 0. Divided by 2 times -1, 0 divided by anything is just 0. So then my axis of symmetry is the y-axis. That's the vertical line, x equals 0. All right, then I put that in the middle of my xy table, and then I finish finding my vertex. My vertex is at 0, comma, 0 squared is 0. -0 is just 0. 0 plus 9 is 9. So my vertex is at 0, comma, 9. Then filling it in to the right, I will use 1, 2, and 3. To the left, I will use -1, -2, and -3. I'm going to choose to plug these numbers in and then mirror image them. I'm choosing these numbers instead of these numbers so I don't have to deal with the negative. So 1 squared is 1. Make it negative. -1 plus 9 is 8. So I have a point at 1, comma 8. Using symmetry, that means I also have a point at -1, comma 8. Plugging in 2, 2 squared is 4. -4 plus 9 is 5. When x is 2, y is 5. Then using symmetry, that means when x is -2, y is also 5. When x is 3, 3 squared is 9. -9 plus 9 is 0. And using symmetry, that means when x is -3, y is also 0. Connecting the dots with a nice smooth curve. And then we find our solutions by looking for those x-intercepts. The x values when y is 0. So this has solutions of -3 and +3. And then with this last one, again, I start by identifying that A is -3, B is 6. I don't have a C, so C is 0. My axis of symmetry, x equals opposite of B over 2 times A. Well, opposite of 6 is -6 divided by 2 times -3. 2 times negative 3 is negative 6, and negative 6 divided by negative 6 is positive 1. So drawing my vertical line through x is 1 and putting 1 in the middle of my xy table. Now finding the rest of my vertex. I've got the x coordinate. The y coordinate is negative 3 times 1 squared plus 6 times 1. Well, 1 squared is 1. 1 times negative 3 is negative 3. 6 times 1 is 6. So the negative 3 plus 6 is positive 3. So my vertex is at 1, 3. Then filling in the points on either side. To the right, I will use 2, 3, and 4. To the left, I will use 0, negative 1, and negative 2. All right, 0. When x is 0, it's my y-intercept. It's my c value. And in this case, my c value is 0. Then using symmetry, I get when x is 2, y is also 0. When x is negative 1, y is negative 9. Which means when x is 3, y is also negative 9. When x is negative 2, y is negative 24. That goes off the graph, so we're not going to graph it. And then that also means that when x is 4, y is also negative 24. So connecting the dots, and that get a nice smooth curve. Finding my x-intercepts. Finding the x values when y is 0. This quadratic has solutions at x is 0 and x is 2. All right, I want to now take this time to review the discriminant. So we talked about the discriminant in last week's instructional videos when we talked about quadratic formula. The discriminant is that b squared minus 4ac part of the quadratic formula, the part that is under the square root. So my discriminant is b squared minus 4ac. We can use it. It is used to determine the number of solutions. So remember, it doesn't tell you what the solutions are. It just tells you how many. So make sure you read the problems correctly. Read the instructions carefully so you know what they're asking for. Find the solutions means find the actual answers. X equals 0 and 2. Find how many solutions means look at the discriminant and decide if the discriminant is positive, there are 2 solutions. If the discriminant is 0, there are 1 solution. And if the discriminant is negative, there are no solutions. All right, in these last examples, they're asking us to use the discriminant to determine the number of solutions. So don't find what they actually are. Just tell me how many there will be. All right, so I start, though, the exact same way I've been doing all these problems. I need to identify in number 7 that A is 1, B is 5, and C is 4. Then I take these 3 numbers and I plug them into my discriminant formula. B squared minus 4AC equals 5 squared minus 4 times 1 times 4. Well, 5 squared is 25. Negative 4 times 1 is negative 4 times 4 is negative 16. So 25 minus 16 is 9. 9 is positive. It's greater than 0. So what does that mean for this problem? This problem has 2 solutions. Doing the same thing in number 8. Y equals x squared minus 3x plus 10. First, I identify that A is 1, B is negative 3, C is 10. Then I plug it into my discriminant formula. B squared minus 4ac is negative 3 squared minus 4 times 1 times 10. Well, negative 3 squared is 9. Negative 4 times 1 is negative 4 times 10 is negative 40. 9 minus 40 is negative 31. This is, excuse me, negative 31 is a negative number. It is less than 0, so that means this problem has no solutions. All right, same thing for number 9. A is 1, B is 10, C is 25. So my discriminant, B squared minus 4ac, is 10 squared minus 4 times 1 times 25. Well, 10 squared is 100. Negative 4 times 1 is negative 4, times 25 is negative 100, and 100 minus 100 is 0. When the discriminant is 0, that means this problem has one solution. In number 10, A is 2, B is negative 4, C is negative 3. My discriminant, B squared minus 4ac, is negative 4 squared minus 4 times 2 times negative 3. Negative 4 squared is 16. Negative 4 times 2 is negative 8. Times negative 3 is positive 24. So that is 40, which is greater than 0. So that means when my discriminant is greater than 0, when my discriminant is positive, this one has two solutions. Number 11, y equals 4x squared minus 12x plus 9. A is 4, B is negative 12, and C is 9. So my discriminant, B squared minus 4ac, negative 12 squared minus 4 times 9. Negative 12 squared is 144. Negative 4 times 4 is negative 16. Negative 16 times 9 is negative 144. Negative 144 minus 144 is 0. When my discriminant is 0, there is one solution. And lastly, number 12, y equals negative 3x squared plus 5x minus 8. My A value is negative 3. My B value is 5. My C value is negative 8. So my discriminant, B squared minus 4ac, equals 5 squared minus 4 times negative 3 times negative 8. 5 squared is 25. Negative 4 times negative 3 is positive 12. Positive 12 times negative 8 is negative 96. 25 minus 96 is negative 71. That is less than 0. So that means this problem has no solutions. All right. That's it for our instructional videos. I hope to see you all in the live sessions. Have a great rest of your day, guys. Bye.